This video will walk you through all of the analyses that you'll be doing today in Excel to complete your lab assignment for Lab 2. Make sure that you have the Data Analysis Toolpak installed in Excel. I already have it installed, but I'll show you how to install it just in case you don't. So before you go to install it, you can check to see if you have it installed by clicking on the Data tab up here in Excel. And if you have this little data analysis, then you're good to go. If not, you need to add it by clicking File, Options, Add-ins, and then you'll want to make sure that this Analysis Toolpak is selected. Then you'll click Go. Make sure there's a check next to the box where it says Analysis Toolpak, and then you'd click OK. And that'll give you the Analysis Toolpak that you'll need to do the t-test that you're going to be asked to do for today's lab. So if we look at Lab 2, you'll see that this data looks very familiar to the data that you saw in Lab 1. So in Lab 1, we were just looking at the differences in the mean and the standard deviation for these two, and we calculated some z-scores. But remember, I asked you to determine if you thought that the time management workshop was effective. Or in other words, we gave the time management workshop after the fall semester, and then we compared their GPA before it to their GPA after it to see, is there a larger mean for spring? And if so, we said, yeah, it was effective. Well, now this time we're going to take that a step further, and we are going to see if there's a significant improvement in GPA after the time management workshop in spring. And we're also going to look at seeing if the sample before they were manipulated, if they represented the population of non-traditional students at NSC. So remember, this comes from 30 randomly selected students who are non-traditional students at NSC. We'll see if they actually represent non-traditional students as well. Okay, so the first thing that you're going to be doing is a single sample t-test. And basically, we're going to compare our sample mean in the fall, before we manipulated anything, to the population mean, GPA, which is 3.0, to see if they represented the population before we manipulated that time management workshop. So Microsoft Excel doesn't actually have a single t-test option, so we're going to trick it into doing it for us. So let's go ahead and copy and paste our data into Excel. So I'm going to left click that little four-cornered arrow, hit Control and C at the same time to copy. Then when I go into Excel, I'm just going to highlight all the way from A1 to B31 and hit Control V. And I know that's the space that it's going to take up because I have 30 people in my data set. And I also have one row that's going to be taken up by labels, so 31 rows. And then I also have two different measurements, so fall and spring GPA. So I'm going to, again, trick Microsoft Excel into doing a single sample t-test by creating a new variable that I'm going to call population and just putting my population mean for all of those different rows. So if you look here, your population mean is 3.0. So I'll just type in 3. I could type in 3, 3, 3 all the way down, or I could just select one of these 3s, go to the bottom right corner where that black plus sign shows up, and just click and drag, and it will autofill the same value. So now to do the single sample t-test by tricking Excel, make sure that you have data selected up here, and then data analysis, click on that. Then we are going to select t-test assuming, or two sample assuming unequal variances. Now these two sample t-tests will make more sense when we start to cover chapter 10, but for now just know that this is what you need to select to trick Microsoft Excel into doing the t-test that we want, which is the single sample versus the population. So click OK. Variable 1, select your sample, including the label. Then click into this box for variable 2. We'll select all these 3s representing the population mean, including the label. Then make sure that you check this box labels so that Excel knows that the first row represents the labels of your values. Then you don't have to put anything here. The default is 0, and that's perfectly fine. The hypothesized mean difference is just the mean difference that we would expect to see if there was no effect of the independent variable in this case. Our alpha level is 0.05, which you'll see right here, significant 0.05. So you can just leave it as the default of 0.05. And let's go ahead and we're going to create a new worksheet with this output. And what that'll do is it'll create a new tab down here that just has the output for this t-test within it. That gives us all the information that we'll need. And let's go ahead and label this as t-single, since that is the test that we're doing, so we can stay organized. So let's go ahead and click OK. Let's see what went wrong here. So we select the whole population. And now let's click OK. Hooray, it's better. Okay. So first thing, if you look at the lab, I'm repeatedly asking you to round to the thousands place, which is 3 decimals out. So we can just go ahead and select all of our numeric values here. Right click, format cells, then click number, and just say we want to go 3 decimal places out. That way you don't have to worry about any rounding. Now to make sure that we can see everything that's in all these cells, we can go up here where the double-sided arrow appears and double click and just do that for each one. And it will automatically adjust the width of the cell to fit the contents within it. So now we can look at this, and I'm going to go ahead and make this a little bit bigger so you can see it a little easier. So let's go ahead and interpret this output. So this just tells us that the mean for the fall GPA was 3.117 compared to the population, which we put in manually. This is our variance. So when you go to write up your APA style conclusion in number 6 for this one, you'll want to take this and take the square root of it to get the standard deviation, because you'll be reporting the standard deviation in your conclusion. So remember, the standard deviation is just the variance, and you take the square root of the variance to find the standard deviation. So there you go. Take the square root of that. That'll give you what you need to report in the conclusion. Then the hypothesized mean difference, under, assuming that there is no mean difference, was 0. You can change this value depending on the context of the problem, but for our purposes, it's always going to be 0. Our degrees of freedom is 29. We had 30 people in our sample. 30 minus 1 is 29. Here is your t statistic. So this is your t obs, your t observed, that you would find in step 3 if you were doing this by hand. And what this tells you is that the observed difference in GPA between the sample and the population is 1.08 times larger than you would expect to see just by chance. So even, basically what this says that there's not much more of a difference between the sample and the population than what we would expect to see just due to random sampling error. So we can say that this sample of students, before they had the time management workshop in the fall, their GPA is pretty representative of the population of students at large who had a mean of 3. So think about that. If this was 1 times larger, then it would be identical value to the population mean. So 1.08 times larger is not much larger. We can also see that this sample represents the population, or that it's not significantly different, by looking at the critical value and the p-value, which can both give you sort of the same conclusion, but not necessarily the same information. So if you look at the lab assignment, we're just looking for a significant difference. Significant difference. This is a two-tailed situation. So we want to pay attention to the two-tailed p-value and the two-tailed critical value. Now this value right here, this 0.289, this is the p-value that you'd be reporting in number 6 for your APA style conclusion. And this tells you the exact probability of type 1 error. Or in other words, the exact probability that the difference between the fall GPA, so the sample, and the population is just due to random chance, not due to any systematic differences. Like we took a sample that's systematically different from the population, had a higher or lower GPA. So the way that you could interpret this, it's easier if you do this in terms of a percent. So we could say that there's a 28.9% chance that the difference in GPA between the sample and the population mean is just due to random chance differences. So that's what this tells you. Now this will also tell you whether or not this finding is significant, or if we can reject the null hypothesis, because our alpha level is 0.05. 0.05. So this is basically saying that we're willing to accept a 5% chance of type 1 error, or a 5% chance that the observed difference is not systematic. It's just due to some sort of chance error. This is less than 0.05, or sorry, greater than 0.05. So we would basically say that there is not a significant difference. The chance of type 1 error is too great for us to be confident that there is some sort of systematic difference between the sample and the population. And in this case, that's a good thing, because we were hoping that the sample represented the population. We were hoping there wasn't a significant difference, and that's what this tells us, because this is greater than our alpha level. It's not a significant difference. We can also make that conclusion based on the critical value for the two-tailed test. So if we compared our observed t-statistic to this critical value, this would not fall in the critical region set by this, and we would also fail to reject the null hypothesis and conclude that there is not a significant difference between this sample and this population. So that is what we would do for the t-test for the single sample. Although it says two sample assuming equal variances, remember we had to trick Excel. Now let's go ahead and look at the next problem in our lab. Just a quick side note, you will be writing up your conclusion in APA style, and I reference the pages in the textbook that you'll want to look at for the 7th and the 8th edition for an example on how to do that. Okay, the related samples t-test. So now this is where we get to a more refined experiment, or a more refined analysis to determine if there's a significant increase in GPA after the time management workshop. So we're wanting to see if there's a significant improvement in GPA after students in the sample participated in the time management workshop. Significant improvement tells you that we're doing a one-tailed test, so we'll be looking at a one-tailed p-value and a one-tailed critical value. And let me show you how to do the analysis in Excel and interpret it. So let's go back to sheet 1 where our data is. And you'll make sure that the data tab is selected. You'll click data analysis. Then you will select the t-test paired to sample for means. This is the related samples t-test in Excel. And click OK. Variable 1 will be our x2 in this case, so our post-test. It didn't seem to copy it correctly. I'm going to delete that and I'm going to highlight again. Alright, that looks good. And then fall GPA will be our variable 2 in this case. Go ahead and keep this blank. Make sure that you select labels. Alpha level still 0.05. And let's go ahead and call this pre-post test T. Just to keep things straight. We're going to have a new tab down here when we click OK. Just like before, let's go ahead and fix these values to be rounded to the thousands place. So highlight, right click, format cells, number, and then 3 decimal places out. Click OK. And let's go ahead and make sure that the cells fit the contents by doing the double click with the double-sided arrows. So now looking at this, I'm going to make this larger again. The mean for the spring GPA was 3.437, and the mean for fall was 3.117. So we can just see already that the spring GPA had a higher mean than the fall GPA. So that's encouraging because this happened after the time management workshop. It looks like they improved. Here's your variance for both. You're going to want to report these in number 12 where you're writing your conclusions in APA style. Just remember that you'll take the square root of this variance to find the standard deviation. Then we'll get to the Pearson correlation in another chapter. We're not there yet. Hypothesized mean difference, 0. That's fine for our purposes. Degrees of freedom, still 29. We still have 30 different people. 30 minus 1 is 29. Now here is your observed t-statistic, this 4.85. And what this tells you is that the difference between spring and fall GPA is 4.85 times larger than the difference expected by chance. So even if the time management workshop had no effect on GPA, that's what I mean when I say expected by chance. So it's quite a bit larger than what we would expect to see just due to random sampling error. Well, let's see if that's significant. So remember, we're doing a one-tailed test, so it's a good thing that we put our variables in the way that we did because we've got the positive value for t, and we're looking for a one-tailed test in the high end of the distribution. So let's look at the one-tailed p-value and the one-tailed critical value to make sure that this is actually significant. It's large enough to say that yes, there is a significant improvement in GPA after the workshop. So this p-value is essentially nothing the way we're looking at it now with rounding. If you click on the value, you'll get to see the actual p-value up here. And you can see that it's not 0, but it's pretty close to 0. So the way that you can interpret this, based on the way it's rounded, is that it's very, very unlikely that the difference between the spring and the fall GPA is just due to chance. Then that means that it's highly likely that this observed difference is actually due to the time management workshop, the manipulation of the independent variable. When you report this in your step 12, make sure that you report p less than 0.001, not p equals 0.000. And that is just to show that you realize that, yeah, there is some probability of type 1 error, but it's less than 0.001 within our rounding here. It's actually 0.000019. That's fine. So just p less than 0.001 is how you'd report that in APA style. We can also tell that our finding is significant, that spring GPA is significantly higher than fall GPA, by looking at this critical value. So our observed t statistic would fall in the critical region set by this critical value. So that's another way that you can tell that this is significant. Now make sure when you do your lab that you reference these pages if you have the 8th edition, page 324, page 318 through 319 of the textbook if you have the 7th edition, for how to write up this conclusion in APA style and make sure that it adheres to that very, very closely. I am going to be pretty picky on the APA style requirement for these write-ups. So I hope that this video was useful and showed you how to get everything that you need out of Excel for your lab. And if you have any questions, feel free to ask. If you aren't in class anymore, you can send me an email and or stop by my office. Thanks.